That looks nothing like my math that I do. This doesn't look like my classroom either. You know, Mom keeps making these videos. I bet I could make one just like her. But this looks nothing like my classroom. 1 second. So much better. I mean, doesn't this just look like my classroom? I mean, so many things that represent me around here. I want to thank my brother, my sister, and brother-in-law for showing up for the lesson. I mean, big props to y'all. Thank you. 1 second. Who put these in my classroom? No. We know these are a no-go in Mr. Jerkins' room. I gotta throw these out. It's a much better classroom now. I feel much more at home. And I know many of y'all are missing out on so many things with having to be at home and the social distancing. I'm missing out on my Disney, obviously. I just want to shout out to my pins for today. We've got our wonderful Haunted Mansion ghouls right here, the Ghastly Manor ghouls, representing some Haunted Mansion and Magic Kingdom. And because no one quarantines like Gaston, rocking the Gaston tie, of course. I know what you're all really waiting for. It's been my favorite part of every day since the beginning of 2020. We've got some quotes of the day. Not just any type of quote, of course. There are demotivational quotes of the day. One of our past ones that you've missed. My hobbies are eating and complaining that I'm getting fat. So appropriate right now. But most importantly, today's April 1st. Daily affirmations. Your hair is so much better than it was in middle school. See, y'all don't get that, but you will. One day, you'll look back and think, my goodness, why? Don't worry, it's okay. Word of the day, Disney. Well, I think we should do some math. Let's get to some notes. X-Men, be sure to pay attention. This will be on the test. All right, it's time. Got a couple things up here on the board. We're doing a little bit with quadratic functions. That's what you're working on in Ingenuity right now. So we're going to start with graphing. Remember, we've done this before. This is all review. So no need to freak out, no crying, no getting upset, no hyperventilating. Just, it's easy. Remember, we're going to start with graphing y equals x squared plus 10x plus 26. If we're going to graph this function, we need to find a couple things first. The first thing we look for is, of course, thank you, yes, the axis of symmetry, totally. And we find that using our axis of symmetry formula, which is, you're right, yes, x equals negative b over 2a. Wait, there are letters involved, they're not x. Where do we find these letters? Where do we find them? Of course. We find in our equation, is because we're in standard form, we know that a is our coefficient of x squared. B is our coefficient of x. And C, of course, is our constant at the end of the equation. So all we have to do is plug in these numbers into our equation. So our axis of symmetry is at negative 10 over 2 times 1, which equals negative 5. It gives me another important piece of information. It lets me know the x-coordinate of my vertex. How do we find our y value? Well, we're going to have to do a little math here. I know it sounds crazy. We're going to set up, I'm going to move down the board a little bit. This part's a little bit weird. We're going to make a little table here. As you all know, I like having 5 spots here. Put our x value for our vertex in the middle. We're going to find 2 values that are greater, 2 that are smaller. We're going to plug in negative 5 into our equation, find out what y is going to equal. So I plug in negative 5 into the equation. We get negative 5 squared plus 10 times negative 5 plus 26 is 25 minus 50 plus 26 equals 1. We can actually come up here into our coordinate plane. And go ahead and plot that point at -5, 1 for our vertex. Sorry. I think I'm going to have to extend my graph a little bit because that's my vertex. And we know we're going to be symmetrical across a vertical line through that point. I need to add a little room on the edge of my graph. Now we're going to do a little more math. We're just going to plug in some more values into, or plug in a few more values. We can choose either -4 or -6. It's 100% your call. But when we do, I'm going to use a better colored marker than that one. Give me a second to do the math. No sports ever. Oh, you've done it now? Good. The answer is 2. So now I go to my graph and at -4, 2, put a point. At -6, 2, put a point. Ooh, let's get a little bit better there. We're just saying a little bit of math again, except we're going to use -3 instead of -4. And a little time to do a little bit of math. Wait for it. As good district practice, we know we wait. Got an answer? It is 5. How about that? The crowd is doing so good with these questions today. So, 1, 2, 3, 4, 5. And I got 1 going through my equation. That's okay. I'm able to graph my quadratic equation. We know that our domain for this function is all real numbers because there's not a value of x that's going to be excluded from this function. Any value of x we plug in, there will be a value for y. And we also know that our range is going to be all numbers greater than or equal to 1. Why? Since a is positive, we know it's y greater than or equal to. We take the y value of our vertex. Sweet. Now we move over to another question. Very simple. And you're going to get to do this one. And so what you need to do right now is pause the video, and then we'll see how we did.
1 eternity later.
Hey, look at this. You have the same answer that I do, right? Right? Okay. Oh, we found our vertex. We found our axis of symmetry is x equals 3, which means that's the x value of the vertex. We plug in 3 into our equation. We get 3 as the value for y. So that's my vertex. I'm in the middle of my table. Pick some values for x to use to be able to plot some points, to be able to connect their dots, to be able to make our graph. And we have a graph of this wonderful function. Isn't that awesome? Got one more piece of this puzzle for today, and we'll be done. Oh, that's refreshing. Of course, my classroom would not be complete unless I was drinking a soda. We all know this. Our last part of the notes we're going to talk about today, last little part of this video, finding the value of a function. We've got in function notation, remember that. It's very similar to y. We get our output given an input value for x. Our function is f of x equals 3x squared plus 5x minus 12. We've got to find the value of the function if x equals 2 and if x equals -3. Of course, we all know how to do this. It's totally simple. Since we're trying to find the value of the function when x is 2 for our first one, all we have to do is replace every x with a 2. So, move down a little bit. All I do is every time I see an x in my function, I replace it with a 2. And now we're just following our order of operations. We know exponents come first, so I'm going to square the 2 here. 2 squared, it's just 2 times 2. Now I can do some multiplication. 12 plus 10 minus 12. 12 minus 12 is 0. That makes this a lot easier. That means equals 10. So the value of the function when x equals 2 is 10. What about when x equals negative 3? Again, very simple. All we do is replace every x with a negative 3. So 3x squared, so 3 times negative 3 squared plus 5 times negative 3 minus 12. Again, exponents first. Negative 3 times negative 3 is positive 9. So negative times a negative is a positive. That's, yes, positive, remember? Good. Plus, we've got 5 times negative 3 minus 12. Now do some multiplication. 3 times 9 is 27. 5 times negative 3 gives me negative 15 minus 12. So 27 minus 15 is 12. 12 minus 12 is 0. The value of the function when x equals negative 3 is 0. This video stuff's not very difficult. Like I might be able to make another one of these, I think. We'll see. All right, so enjoy your break. Break from being in the classroom, not a break from school, because of course we still have school. But hopefully this helps with your ingenuity. Hopefully this helps with what we're working on, and we'll see y'all later.